Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through solving equations using flowcharts. So before we get to that, let's just say I have here a machine that adds 2 to a number. So if I put 3 into this machine, out will come the number 5. If I put minus 4 into this machine, it'll add 2, and out will come minus 2. So what would I need to put into this machine if I wanted to come out the number 8? Well, what we would essentially do is start with 8 and put it through the machine the other way. So when we go this way through the machine, instead of adding 2, it would subtract 2. So I would need to start with 6. Let's look now at a machine that multiplies by 3. So if I put 4 into this machine, out comes the number 12, because 4 times 3 is 12. If I put 0 into this machine, out comes 3 times 0, which is 0. So what would I need to put into this machine if I wanted to get the number 15? Well, what we would do is start with 15. We'd go the other way through the machine, and instead of timesing by 3, we'd divide by 3. So 15 divided by 3 is 5. So I need to put 5 into this machine in order to have 15 come out of the machine. So what we're actually doing here is using inverse operations, and it's this principle that we will use to solve equations. So let's say we're trying to solve this equation 2x plus 1 is equal to 7. So what we do with flowcharts is we tell the story of what happened to x. So what did I do to x to get this left-hand side? So I started with x, some unknown number, and the first thing I did was times it by 2. So I put it through a machine that times by 2, then I put it through a machine that adds 1, and then I got 7. Now the order of operations is really important when we're solving equations. Because of BIDMAS, because of the order of operations, the multiplication comes first. So that's why I put the times 2 machine first, then the add 1. So we've got to do this in the order of BODMAS or BIDMAS. So if I want to solve this equation, what I do is I start with 7. What would I have to put through the plus 1 machine to get 7? Well, essentially, I'm going the other way through the machine. So instead of adding 1, I'm subtracting 1, because subtraction undoes addition. So I get 6. So what I'm saying is I would need to put 6 through this plus 1 machine in order to get 7. So then, what would I need to put through the times 2 machine to get 6? Well, the way I undo timesing by 2 is I divide by 2. So 6 divided by 2 is 3. So what I'm saying is I would need to put 3 through this times by 2 machine to get 6. And that happens to be our answer. X equals 3 is the solution to this equation, because if I substitute x for 3, I get 2 times x, which is 3, plus 1 equals 7, and that's a true statement. 2 times 3 plus 1 does equal 7. So this is how we can solve equations using flowcharts. So let's look at a few more examples, and please pause and copy this down if you need. So let's solve the equation 3x minus 6 equals 30. So the first thing we do is tell the story of what happened to x. So I took x, and because of the order of operations, the first thing I did was times it by 3, put it through the times 3 machine. Then I got my answer, subtracted 6, and out came 30. So to solve for x, I need to go the opposite way. So what do I need to put through the minus 6 machine to get 30? And the answer is 36. I go 30 plus 6, which is 36. So then what do I need to put through the times 3 machine to get 36? What number times by 3 gives 36? So if I don't know that, I go 36 divided by 3, which is 12. And that gives me the solution x equals 12. That's the answer, because 3 times 12 minus 6 does equal 30. So you can write it like I have on the screen, or if you like, you can draw the boxes going the other way. So you can start at 30. Instead of subtracting 6, you add 6, which of course gives you 36. And then instead of timesing by 3, you divide by 3. So that gives you x equals 12. So you can write just this line as I did originally, or both lines, whichever way suits you. Now let's solve this equation. It's going to look very similar, but I just have some brackets. So remember, all brackets do is change the order of operations. Now, when you change the order of operations, you do get a different solution. You'll see that the answer to this one is different to the answer than the one I just did. So that's why it's really important when we're solving equations that we get the order of operations right. So what changes is, well, we're still going to tell the story of what happened to x. But what happened is I took x and I subtracted 6 first. I do what's in the brackets first. Then I times by 3 to give me my answer of 30. So the way I solve it is still the same way that I solved the previous one. It's just that because the order of operations are different, I'll get a different answer. So what do I need to put through the times 3 machine to get 30? Well, the answer is 10. 30 divided by 3 is 10. What do I need to put through the minus 6 machine to get 10? Well, of course, I need to put 16, because 16 minus 6 is 10. What number minus 6 is 10? The answer is 16. Again, you can just write this line, or if you like, you can draw the second line with the boxes. So I start at 30. Instead of timesing by 3, I divide by 3. And that gives me the answer of 10. And instead of subtracting 6, I add 6, because I'm going through the opposite way through the machine, and 10 plus 6 is 16. So the answer here, either way you do it, is x equals 16, because 16 minus 6 is 10, times by 3 you get 30. Note the answers in each of these were different. As I said, if we change the order of operations, we get a different answer. All right, now I just want to show you how to do one involving fractions. So let's do this one here. X over 5 plus 2 equals minus 1. Just because it's a fraction, it doesn't mean it's that scary. Just remember that this fraction line here means divide. So when I tell the story of what happened to x, remember division comes first before addition. I took x and I divided by 5. Then I added 2 to get my answer of -1. Now, just because we have a negative this time, it doesn't mean we're going to change how we solve. We're going to follow the same process. So what do I need to put through the plus 2 machine to get -1? So that would be -1 minus 2, because you undo adding 2 by subtracting 2. So that gives you -3. So what do I need to put through the divide 5 machine to get -3? Well, I need to put -15, because -15 divided 5 is -3. -3 times 5 is -15. Once again, you can draw the second line of boxes if you need. So we finish with -1. Going the other way through the plus 2 machines means I'm -2. Other way through the divide 5 box means I times 5. So -3 times 5 gives me -15. So the answer is x equals -15. And we can again check with substitution. -15 divided by 5 plus 2. If you put it on your calculator, you do get -1. So we know we're right. So what if I were to change this slightly so it's x plus 2 over 5 equals -1? So these equations look very similar, and they are very similar, but the only difference is order of operations, which, as I mentioned before, will change the solution. So because I've got the x plus 2 on top, it means I've actually added 2 first. So when I tell the story of what happened to x, I've actually added 2 and then divided by 5 to get my answer of -1. So same process for solving. What do I need to put through the divide 5 machine to get -1? And of course the answer is -5. What do I need to put through the plus 2 machine to get -5? That'll be minus 5 minus 2, which is minus 7. And we can use the next row if we want. Start at minus 1. Instead of dividing by 5, we times by 5. So minus 1 times 5 is minus 5. And then we're going the other way through the plus 2 machine. So instead of adding 2, we're going to subtract 2. And minus 5 minus 2 gives minus 7. So either way, we get the answer x is minus 7. You can put that on your calculator and check. Minus 7 plus 2 divided by 5 does equal minus 1. So once again, slightly different answers when we change the order of operations. All right, thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.